We have the next speaker with us, who's Amita Kapoor. Amita Kapoor is head of data science of Diggity.io, advisor at DeepSight AI Labs, FindLabs.ai, and MarkTech Posts. Mentor at Udacity and Coursera, author of best-selling books on TensorFlow and deep learning, guest tutor at University of Oxford, and associate professor at the University of Delhi. She has over 20 years of experience in the field of neural networks and artificial intelligence, both at the implementation level and in research. She's extremely passionate about using AI for the betterment of society and humanity in general. She continues her work at the intersection of reinforcement learning, probabilistic graphical models, and quantum machine learning. Ma'am, we are extremely grateful to have you with us.
Thank you.
Ma'am, the stage is all yours.
Okay, thanks. I hope the presentation is visible.
It is.
Okay, thank you. Okay, so now without further ado, I start with the session. I will be talking basically about the impact of artificial intelligence on businesses. The idea is to give an overview of what is happening in the field of business startups, especially related to the field of artificial intelligence. But before I start, let me give a little bit introduction about myself. Although Ashwas has kindly introduced me, I still think that it is important for me to tell you about my journey so that it motivates other students. So I started my career in 1996 as a lecturer in University of Delhi, and means like if you see with a lecturer's job, it's kind of very routine job. You have few papers which you teach every day, every year rather, and only the students change. Nothing else changes much, right? And somewhere along the line, although I was doing very well, I felt there is a need for challenge. And to challenge myself, I've always been learning since 1996. All summer vacations, I have been learning something new. So eventually, I decided why not, go for PhD. So I decided to do my PhD after my means while in job. And then somewhere in my PhD, I was selected for a fellowship by DAAD, and I went to Kashmir Institute of Technology to do my PhD work. And eventually, I got my PhD in 2011. Now, this was a world where deep learning was still taking shape. People were still talking about deep learning and everything. I was teaching a paper of neural networks since 1996 and artificial intelligence since 1996. But at the same time, there were limitations, and we were very well aware of the limitations that AI and machine learning imposes. So there were models like support vector machines, which were doing very good, but still the dream that shows that was still missing, right? And then somewhere in 2011, 2012, we had a big breakthrough in the field of AI. And not just in the field of AI, I would also say in the field of education, we had online classes available through platforms like Coursera, Udacity, which I joined first as a student, and then I also became mentor in those particular platforms. And this gave me a broader view of not just the learning part, right? Because the basic theory and things I was already doing. But what it gave me an overview was of the community. I came to realize there are many people around me who are working in the same field, and we can share our thoughts and move together. In one of my course in robotics in Coursera, I met a few people, and we formed a team, and we participated in the NASA's Centennial Robotics Challenge. That was about 2017, right? And in that particular competition, we were in the semifinals. I couldn't compete for this final part because of the limitations of, again, computation at my end. But reaching the semifinal, we got a good amount of, I would say, prize money, which helped me in building my own system later on. And then obviously things changed with Deep Sight AI Labs, and then today I'm teaching at Oxford, and I'm also working at digity.io, where I'm working in the area of natural language processing. I'm making use of the probabilistic graphs, the Bayesian networks, to make algorithms which can help the project managers in doing the project management task. Uh, so this is an introduction about me, and the only thing I would like to say out here is the fact that although I had a permanent job, which is a very well stable job, the simple thing that I have to learn, this concept of learning keeps me going, and this keeps me going even now. And I think in the coming world, what is going to matter is no matter which job you have, whether you have a government job, and this I'm saying because many of my students who are like within in my university, they all think a government job is the best job. So no matter what kind of job you have, whether it is a government job or a private job, learning is an important skill. One should not stop learning, right? And if you continue to learn, the paths are going to always open up for you. Now with this message, I start up with my talk. A brief overview of what I will be talking about is I will be first of all introducing everyone to the artificial intelligence, since I was not very much aware of the skill set of the students who will be attending the webinar. I'm starting from the basics and I will be going to the depths, right? So I will be starting up with the introduction to artificial intelligence, where I will be talking about the growth of artificial intelligence in the last 3 years, specifically with terms to the businesses, and then the challenges, plus I will also talk about the way forward. So I will talk about the basic history and some major milestones in artificial intelligence. I will talk about the fundings, the startups, and the demographics which have taken place in the last 3 4 years. And then finally, I will talk about the way forward, how we can go ahead and learn more. Right. So this is the brief overview and the brief objective of my talk today. Artificial intelligence is something which is today part of almost everything, whether we are aware of it or not. It is some part of artificial intelligence or machine learning algorithm is working there. You can choose any field and you will find that it is there. For example, designing new compounds, gene sequencing, creating art, disease detection, writing books, even create grading the answer sheets, face recognition. Then we have legal advisors which are based on AI things. We have financial advisors or financial market advisors available. Then there is machine translation, music generation, and robotics. So these are many fields which are existent in the field, basically in this particular area, which you can see that all of them use artificial intelligence. No matter where you go, whether you talk about retail, whether you talk about cybersecurity, whether you talk about communication, telecommunication, transportation, AI is being used there, right? And as we all know, it has not means we are hearing about AI only from the last 1 decade more. Before that, it was not that much in hype, not that much in use as well, right? So the question arises, is it a new technology or is it an old technology? So here I would like to say that it's not really a very new technology, to be honest. It was initially proposed somewhere in 1943. Means I would say that that was the birth time of the present deep neural networks that we see. So in 1943, this was a time when even we did not had the computers. Like the first computer was completed in 1946, right? This was the time even before the computers when Baron McLeish and Walter Pitts they proposed a model in their paper, a logical calculus of the ideas immanent in nervous activity. And their model, which we call as McLeish-Pitts model, what it could do was it could basically perform logic. It could do calculations which concerned logic, right? Something which till that time was not considered to be possible by machine. So they propose that if it is possible to build a machine which can do logical thinking, the inspiration for McLeish-Pitts model and all the neural networks which followed is basically the human brain. Now, when I say the inspiration is human brain, what I basically mean is, first of all, that we are trying to imitate the concept that there are units which we call as artificial neural networks, and we mimic the concept that these artificial neural networks, when they are connected in a particular manner, they can perform intelligent thinking and intelligent task. right? So that is the major inspiration behind the development of the field. And there are certain features of human brain which kind of motivate us and which we are still very far off sometimes, I would say. So for example, our brain consists of 10 to the power 10 neurons. So now in terms of neural networks, we can call them parameters. So yes, today we have models which can say that they have a very large number of parameters, but still nowhere near 10 billion neurons. Then the switching time of our neurons is very roughly 10 to the power minus 3 seconds or 10 milliseconds. We can recognize a face in 0.1 seconds. These are the things which now even the AI can do, right? We can perform large number of high degree of parallel computation, again something which has been made possible with the help of GPUs in the present time. We have a distributed representation, and the important thing is we have a graceful degradation and we are robust. Now what do I mean by this and why I call it important? Because this is something which we are still not up to the mark. Like robust, we have still reached that if there is an input which is faulty, my AI is able to still get an understanding and can see what it is. But graceful degradation is something which is still missing. What graceful degradation really means is that even if I age, so if I become 40, I become 50, I become 60, there is a degradation. I'm not that active at 60 as I'm at 50. I will not be that active at 50 as I was on 40, and so on, right? But that degradation is slow. It's not that suddenly I crossed a mark of 45 and no, I can no longer function the same manner. And when I say function, it's not just a physical function, it's also the mental function, right? So mentally we remain quite active even at 80s. So we have a graceful degradation, right? And this is one feature which we still are trying to get in our artificial machines, and maybe one day we do get that part, right? And important thing that again which is still missing in the AI is that no matter what we can we can learn anything, right? So it's not that if I was trained as an electronics person, today I cannot shift to, let us say, psychology. No, I can read on that and I can work in the field of psychology, or maybe in the field of project management or any other XYZ field. Why? Because I can learn. That is like our brains are generalized learning machines. They can learn anything. So our general intelligence is still yet to be built in the area of artificial intelligence. So these are some of the dreams which we have. So as I said, the starting of AI is as a field started from 1943. Then came the next milestone, uh, the terminology of artificial intelligence that was coined by John McCarthy in 1956. All right. And what they meant by means it was basically a part of a conference in Dartmouth where many, influential scientists and professors, they, combined together to work together on a field on this particular area. And what they proposed as artificial intelligence was machines which are capable of perception, logic, and learning. All right. Now, if you just go back, when I introduced you McLeod-Pitts, I said they can do logic, but I never talked about perception and learning. So that is two important things which should be possible in the machine. So that is what these people proposed in that particular conference, and the term artificial intelligence was coined. Very soon, we had Frank Rosenblatt, who proposed a artificial neural network which could not only do logic like McLeod-Pitts model, but it could also perform learning. And he gave this particular model and he wrote this book in which the whole model is there: Principles of Neurodynamics, Perceptrons, and the Theory of Brain Mechanisms. Right? So, this is where he gave the first neural network to the world. And in the book, what he says is that the perceptron is the embryo of an electronic computer that expects will be able to walk, talk, see, write, reproduce itself, and be conscious of its existence. So please remember, this is something which Frank Rosenblatt said somewhere in 1962 about neural networks and about the perceptron model that he built. All right. And as a result, there was lot of hype generated around neural networks, lot of work, lot of research, lot of people started working in the particular area, right? Because it provided a hope which said that a lot of things are possible because it could learn. And was a very big achievement at that particular stage. However, things did not remain very nice for artificial intelligence or neural networks, as they were called at that particular stage. And we had a very detailed study on perceptrons and their capabilities by Marvin Minsky and Seymour. And what they proved was that perceptron, it cannot solve non-linearly separable problems. Plus, the training time, it is growing exponentially as the number of inputs are increasing. So these two were very big, I would say, issues, right? Why they were very big issues? To understand that, it's important to understand what we mean by linearly separable and non-linearly separable. So in this graph, you can see that the graph on the left is linearly separable and the graph on the right is non-linearly separable. When it is linearly separable, it is a simple problem. We can have a demarcation line which is separating. It's linearly separable, so demarcation is through a line which is separating one class to another. But when it is non-linearly separable, I cannot have a line. I can draw a circle in this case and separate out the circles and the triangles, but I cannot have a line. Now, why is it important? It is important because while an AND logic and OR logic, they are linearly separable, as you can see from the curves on the right side, the XOR problem is non-linearly separable. You can see cannot draw a single line which can separate the black dots from the white dots. All right. So this is not possible. And XOR is one of the simplest problems. Right. So it's basically mutually exclusive thing. And many things in our life, in our day-to-day work, they are mutually exclusive. Many decisions which we take, they involve mutual exclusive decisions. All right. So as a result, this was a big problem, and this resulted in what we call as the first AI winter in from 1974 to 1980, right? And some of the reasons for this particular failure, I will just put it up out here, was definitely that, as we said, it cannot solve nonlinear problems. Then people did try to use it for machine translation, which failed drastically at that stage. They tried to use it for speech understanding. Again, the results were not up to the mark. And then there was a paper by James Lighthill, in which he basically made a survey of all the work which was being done in the field of artificial intelligence, and he's kind of his paper reviewed, and he said that the AI researchers, they have been able to address the issue of combinatorial explosion. So whenever we talk about the real world problems, the number of inputs are very large, and as a result, the amount of time taken becomes too large, and there is an explosion of time. Plus, as a result, the AI techniques, whatever they are there, they can work for small problem domains, but will not scale up when we talk about the realistic problems. All right. And as a result, since it cannot work for the realistic problems, the whole hype and the interest which was generated in the neural networks, that kind of, freezed, which resulted in the AI winters. Right. Now, the thing is basically, again, comes what next? If there is a freeze and nothing is happening, is there a way out? So even at that stage, there was a possibility that if we can connect many such artificial neurons together, means even the Rosenblatt had given in his book that if we can connect many such artificial neurons together, we will have a neural network, a multi-layered neural network, and that will be able to solve nonlinear separable problems. The only problem was he could not find out an algorithm to train such a multi-layered perceptron. He could find he had an algorithm to train a single perceptron unit of some neuron units which are in a single layer, but he did not have any algorithm which can train a multi-layered perceptron. All right. Why is it so? Because his algorithm was based on correcting the error. So I know the error at the output, but there is no way for me to know the error in the hidden neurons, right? So there was no way of doing it. And although the model was being proposed in 1960s itself, we had a solution by uh, Rumhalt, Hinton, and Williams in 1986. So what they did was they used a algorithm which was already being used in the area of control theory, and they used it to train a multi-layered perceptron. So whatever problem was there in 1960s, they proved that it is possible for us to solve it and train a multi-layered perceptron using the back propagation algorithm. So again, this was a big achievement, and this kind of paved way for interest in neural networks to return. But still, the growth was slow, and it's only in the recent decade that the final growth has taken place. So now the question arises, what has happened in this last decade? Means algorithms, they were built, the concepts, they were there. So what new has happened in the last decade that has resulted in the growth of AI? This is also important to know, because unless we know that, unless we think it is just hype, then there is always a chance of another AI winters, and we do not definitely want that to happen. So the growth or the driving force behind the growth of AI in the last decade is, first of all, the availability of large amount of data, and the second, the presence of hardware accelerators, the graphical processor units and the tensor processor units. How they help and how they can work it out, we will definitely see again. So these are the two driving forces which have resulted in the large amount of the exponential growth of AI as we are seeing. And here I would like to point out the quote by Satya Nadella, CEO of Microsoft. And he says the core currency of any business will be the ability to convert their data into AI that drives competitive advantage. The data is the fuel of AI, right? And if you see from this graphics, you can see that in 2016, while we were generating only 44 billion gigabyte per day, by 2025, we will be generating 463 billion gigabyte per day, which you can see is a big increase in the amount of data that will be generated. And this is per day data, right? So earlier we did not had that much amount of data with us by which we can train our deep neural networks. All right, but today we have so many sensors available and so many low cost things available. For example, internet is there, which is generating lots and lots of data. Each one of us have our mobile phones in our hands, clicking photographs, sending messages. They all are data. Social media, we are putting our thoughts, our information on the social media. That is data. The CCTVs continuously capturing us. They are providing the data, the health monitoring sensors, the watches that we are wearing, and other health devices that we are wearing. They're continuously monitoring the health, smog sensors, alert water sensors, and motion detector sensors, and so on. So these are the large number of sensors which are continuously being placed and collecting data continuously, right? And this particular data is the fuel which is going to uh, bring us even better results in the coming future, because this is not going to go unless something totally unexpected happens, right? Okay, so I guess this is one important part which I have been able to convince you. And now what I'm going to tell you about is how the things have changed from the 1960s, 70s, that is just before the first winter, and today. All right, to see that we have really undergone this drastic change. So this comparison is based on Fershine paper, forecasting and assessing the impact of artificial intelligence on society. So he basically forecasted certain technologies which should be possible in the case AI is really capable. Okay, so he talked about automatic language translator. And when he talked about automatic language translator, what he meant was that there is a language translating device which is capable of high quality translation of text in one foreign language to another, either technical or even commercial material. So today we have Google translators. There is Bing translator by Microsoft, right? And they have been improving. As you can see from this graphics, the one on the left is the translation that it did in 2014, and the one on the right is the translation it is doing in 2017. So you can see there is a lot of improvement in the way our machine translation is happening. All right, and it is even improving now. It's a continuous learning process. It is even improving now. So we can see that this forecast, which he did in 1973, is today possible. Another thing that he talked about was automatic diagnostician. So what he meant by that was a system which is capable of interactive and or automatic medical diagnosis based on querying the patient, an examination of biological text, and etc. So basically it was a system which should be able to detect any diagnosis based on some parameters, some census values that are being there. Today we have Apple Watch. Apple Watch can do your ECG, it can do your heart rate, breathe rate, even oxygen checking, and all that stuff, right? Then we there is Qualcomm tricorder. It is still not out for commercial release, but it is inspired by Star Trek, and it is basically a real life version of the tricorder. And the idea is to make a device which is somewhere around 5 pounds or less, which can continuously monitor the vital signs and diagnose different disease states. And it should be used not just by medical professionals, but by anyone. And it is in the process. There was a competition held by X Prize, and there were winners who were able to achieve it and do it as a proof of concept. But yes, from that proof of concept to coming to the market takes time. So it is still in that particular process. Another thing that he detected was robot chauffeur. So what he meant by robot chauffeur was robot cars which are capable of operation on standard city streets and country highways using visual sensors, right? And today we have Waymo by Google. There is Cruise, which is launching the self-driving cars in the area of California, the Baidu, which is doing the same thing in China, and so on. So there's a large number of self-driving cars. Even Apple is investing a lot of money in car. Uber has its own self-driving cars. So you can see this is something which is happening, and it is not just happening; it is like already implemented in some of the cities altogether, right? So this is again one of the forecasts which I did, which has become a reality today. 10 universal game player. So what his idea was that there should be a system which is capable of playing any game, and at particular controllable level of proficiency, starting from a novice level to a master level. So that means the computer system does not know anything about the game in the starting, but just by playing it becomes master or expert into that. And we had AlphaGo, and then later AlphaZero, which is totally tabula rasa. That means it has no information at all from the starting, and it was able to defeat AlphaGo and do solve the task of play the game of Go, right? And to tell you why it becomes important, or why AlphaGo was such an important achievement, I would like to tell you a little bit about Go. So it's basically AlphaGo was the first computer program which defeated a professional human Go player. All right, and Go by itself is a game which is a very which has a very profound complexity. And why is it so? Because in it there are about 10 raised power 170 possible board configurations. That means you cannot do a normal tree search. All right, so it was very difficult to use conventional search algorithms and conventional functions to make a program which can do AlphaGo. All right, which can work with the AlphaGo. But then using deep neural networks, advanced research mechanisms, and reinforcement learning, the AlphaGo was built. And finally, in the March 2016, AlphaGo defeated Lee Sedol in a 5 game match, right? And that was the first time a computer program, it won a professional, a 9 dan professional, that is the highest level professional in the game of Go. And after AlphaGo, the DeepMind, the team which made this AlphaGo, they also came up with AlphaZero. The AlphaZero had absolutely no knowledge at all. Like in the case of AlphaGo, they even had some Monte Carlo search techniques where some information was there, but the AlphaZero was starting from complete zero state, as Fortune had said. And from that zero state, it learned and learned the game of Go and eventually defeated AlphaGo. All right. And that means we have something which can be a universal game player. It can learn any game by just playing it. All right. So this is some idea which I wanted to give you about the perceptions which people had about AI in 1960s and 1970s. And we can see that although it took a big time, about 50 years, but today we are at the stage where many of those forecasts are becoming reality, which means maybe in coming future some more such forecasts, like for example the goal of artificial general intelligence, hopefully will become a reality. Okay. Now, let us move towards a little bit about the whole system of artificial intelligence. So I call it intelligent agents. So basically, what we are talking about is we are talking about an agent which is able to learn from the environment. So it is an agent which is interacting with the environment in a repetitive sense, think, and act cycle. So it senses, that is, it collects the data from the environment. The data can be images, it can be text, it can be speech. It thinks, that means it identifies the patterns existing within the data or within the perception that it has taken. It has different deep learning algorithms which are working and helping it out to make the decision. And then once it has reached a particular decision, it can act. That is, it has actuators which can complete a particular task. For example, if I have an AI driven, let us say AC, and it detects that the room has become a bit hotter, then the AI detects that the room is more hotter because there's large number of people or whatever the reason is. It basically reduces the temperature so that the room temperature is maintained back to the normal level. All right. So that sort of actuators are happening. Now, this intelligent agent is basically, as you can see, is taking the data from the environment. It is making an informed decision based on this particular input data plus its past experience, and then basically for performing an action which can bring about a change. All right. And this intelligent agent can be a machine. And that's why I took a different name. I'm not just calling it as artificial intelligence. I'm calling it intelligent agent because it can be a robot, it can be a self-driving car, or it can be even a software agent like a chatbot or a recommender system. All right. Some of the tasks that we already have these intelligent agents being performed is the task like, for example, image classification and localization. So we have AI systems which can tell whether in the image there is a human, there is a dog. If it is a human, then which human? If it is a human, then where exactly is the human, and so on. So image classification and localization is a task which has already been done to better than the human accuracy, I would say. Speech to text conversion, I'm speaking and it is getting converted into the text. You can even try it out even with the Google Meet itself. So if you just turn on the captions part, whatever I'm speaking, it will just put it up to the text which you can read and do. And this becomes very useful, especially in this post COVID era when we have meetings throughout, all Google Meets happening, and we are talking with people who are not right now in with us in the place. And sometimes there can be the problem with understanding the accent. There can be problem with the languages in different perspectives. So speech to text can work even in that particular scenario. Then AI based diagnosis of different diseases like breast cancer, Alzheimer's. This is again happening with very high accuracy. Then machine language translation, we have already seen it is kind of almost perfect today. And then artificial intelligent art creators, as you can see, one of the art out here which is being created by AI. So these are the things which AI is able to do in a very broad sense, and it has been able to do in a capacity which is much better than the humans in many cases, right? And there are large number of algorithms which are being used. So this is just a summary of what the tasks are, what the applications are, and what the algorithms are. This is just a broader overview of that. So we can talk about the computer vision, where basically we're talking about the images or the videos and how to process them. So there are tasks of face recognition, image restoration, gesture recognition, and so on. Like for example, in a if I talk about a factory, then the detection of a defect in the product and so on. And it has been found that convolutional neural networks are very good at this particular task. Then there is text analysis, which is basically nothing but information extraction from the textual data, right? So it can be used for document summarization, for fraud detection, for forecasting, for translation, and so on. The recurrent neural networks were used for this particular thing earlier. Recurrent neural networks and their variants like LSTM and JRU. And now we use GPT-3, transformers, word-to-vec, and glove embeddings for our text analysis. Then there is a field of speech recognition where speech is converted to the text. Again, a combination of convolutional neural networks and recurrent neural networks have been utilized for doing that part. And then there is a field of game playing, again, where reinforcement learning as an algorithm is very much in use, and most of the algorithms are basically deep q networks and their variants which are being used. So these are some of the algorithms and some of the areas plus their applications which are right now very much giving successful results to different businesses around the world. So this was a basic idea about what is happening in the area of artificial intelligence. Let us now shift towards the business part. So, I will be now telling you about different industries and sectors which have adopted artificial intelligence, the funding which is available in this particular area, and so on. This graphics is telling you about different areas and the number of AI startups that are working in that particular area and the fundings, right? So you can see we have lot of funding and lot of AI startups in the field of cybersecurity, in the field of healthcare, for financial services, for example, whether a person should be given loan or not, cross industries, that is from one industry to another industry, autonomous vehicles, and so on. This graphics tells you about the sectors and industries which were prominent in different areas. So we had a lot of AI startups in the area of healthcare in 2017, followed by business intelligence, sales, and so on. In 2018, again, you can see that it shifted from means like healthcare is still on in the top 5, but we also had addition of cybersecurity and enterprise AI. And if I move from 2017, 2018 to 2021, that is this year, the top categories beside healthcare is transportation, processors, retail, and CPG. So in the transportation, we already know about Waymo and Cruise. AI processors, Horizon Robotics, Samonova, these are some of the mentionable startups which are working in this area. And then retail and CPG, Trax is one interesting startup which has come up with a great idea, which is being again implemented in many of the showrooms around US. So the idea is the user goes into the retail showroom, you just choose whatever you want to take it up, and all the billing happens automatically. All right, and these startups have generated lots of fund. uh, like for example, the Trax has been able to generate about $640 million, right? So you can see that there's a lot of money being invested into the AI field and a lot of work is getting done. And this is graphics which is giving you the list of some of the prominent AI startups which have been working in this area for some time now, not just 2021, but even before that, who have almost established themselves in these different areas, and they are generating good results. All right. And what I would say out here is, if I talk about 2021, then in this year we had even a record-breaking funding of $20 billion. Means in 2018, the funding was only $1,877 million. Today, is in this particular area, it is $20,000 million. So you can see that it is a vast increase in the amount of funding which is there. A large amount of AI unicorns are being formed, and there is lot of IPOs, mergers, and acquisitions happening in the field of AI. So this is one area which you can say that is there, where lots and lots of opportunities exist. No matter which particular sector you want to work in, you can definitely make use of AI, build up a product which is around AI, and you can launch your work. Now I will be just telling you a little bit about the demographics and how AI is, there. We talk about a global world, but unfortunately in the field of AI, it is not so. So this is in 2017, the status. You can see both US and China, they are dominating. 2018, US and China dominating. 2021, US and China dominating. Means in 2021, US has 41% of AI companies, while China has 19%. So more than 50% share is being taken up by United States and China, right? So you can see that there is a big AI divide. All the countries are not same. There are some countries which are doing a lot of work in AI, and there are some countries which are not doing sufficiently in the field of AI. All right. And this AI divide, this can have lot of negative effects or differential effects, for example, on the availability of the jobs. Now when we talk about AI, you might have heard many people say that if AI comes, the jobs will go. No, it's not basically that. It's basically the type of jobs will shift. Like for example, if I talk about the self-driving cars, yes, we will not need drivers to drive the car, but there will be a requirement of robotic engineers who will be able to handle that particular car, and so on. So that particular part will increase, which will be more than a normal car mechanic, right? And slightly less than a probably full scale or full stack developer. All right. So there will be different type of job skills required, right? But in the case the we do not have, we have this AI divide, then this job opportunities also definitely change. We do not get those job opportunities as well. Then the civic facilities, they change. Like for example, if my transportation is managed by an AI, I will have a better system where we can have a place where there is less pollution and we can reach our destinations on time, right? But if it is not so, then we are obviously suffering as we are doing right now. Then the healthcare amenities, for example, in the field of healthcare, having a system which is AI diagnostic system, having robotic surgeries and things like that, definitely improves the healthcare facility, right? Obviously no one can take place of the doctors, but having these amenities is always going to be helpful and will be providing the scope to healthcare to the patients or the general public. But in the absence of these, with this AI divide, this is not possible. Similarly, the transparency and governance, if we have everything digitalized, the chances of corruption reduces, right? But again, if there is not there, then there will remain countries which are where there is corruption, and whenever there is corruption, the ruling one, whoever rules, they have the highest thing. And then the most important thing, because rest we can still think of, environment is something which will just going to suffer. For example, waste management, and they're all things, this is not possible unless we all have a right amount of AI solutions being done for this, right? So that is again one part which is going to suffer a lot in the case we do not do something to reduce this AI divide. And as a result, means like I would suggest certain steps out here. So one thing is the education part, especially the steps are with reference to India now. So for example, if you talk about the education, the teachers who are teaching within the school, within the colleges, within the universities, they need to be educated about the AI, the scope of AI, what AI can do and what AI cannot do, both. The leaders, they also need to be becoming aware of some sort of there some sort of a AI primer should be there, especially for the leaders, so that they can understand how they can use AI to govern better, not control better but govern better. Then students, definitely there should be an opportunity for the students to learn, and having different online platforms definitely gives the students a lot of benefit, but at the same time there should be more such possibilities for the students. Then infrastructure, we still have places where electricity goes for an hour, for 2 hours, 5 hours, or even 6 hours, right? When we are talking about AI, and if I have sensors installed which is controlling everything, even 1 minute of electricity break means lot of reduction of data and lot of inconvenience cost. So definitely electricity should be available 24 hours cross 7. Computing devices, they should be made cheaper, so that is possible by reducing the export duties on computing devices. Then ease of business should be there. Like Indians should be able to uh, open up companies and startups within India. So there should be transparency in taxes, there should be less paperwork, and there should be incentives. Some of these are already being implemented, and a little bit more can be done about it, right? And with this, I would like to end my talk. I've given you a brief overview about the things that are important in my opinion. And with this, I end the particular talk, and I'm open to the questions.
Thank you so much, ma'am, for this wonderful presentation.